Okay, guys, let me reiterate. We're doing 3 sections in this chapter. It's a short chapter, okay? We're doing the second one today. We are talking about quadratics and diving into their characteristics of their graphs. I will say this. There will be a calculator portion of the test, and there will only be a not calculator portion of the test. You will need to know how to graph quadratics without using a graphing calculator, okay? So our goal today is to be able to graph parabolas, quadratics in standard form, which is something new. We're going to be able to find maximum and minimum values of quadratic functions and graph quadratic functions using x-intercepts, okay? There are 3 ways a quadratic could be in, or I guess 3 forms. The first one is a vertex form. Luckily for you guys, we already know that. Vertex form of a quadratic is f of x equals a times x minus h plus k. That's a review. Now, let's jump over to the vertex. What's the vertex of that graph? HK, excellent. The vertex is at the point HK. Okay, now the axis of symmetry is located, it's a vertical line located at the vertex. Okay, so if it's located, first of all, if I were to write an equation of a vertical line, what's an equation of a vertical line?
A number 0.
No.
That's the coordinates.
If I were to write I'm going to go down here for a second. If I were to write an equation of, let's just say, this line, what's the equation for that line? Talk to the person next to you. Go. Vertical line, no? Does anybody know?
Y equals x minus 2.
No.
X plus 2. X, no, because
No.
the h means lines.
Guys, what's the slope here of this line?
0.
Slope is undefined. It's a vertical line. The slope of a vertical line is undefined. We can't put that into slope-intercept form because how do you put y equals mx plus b when A, there's no y-intercept, and B, the slope is undefined? You can't do it, okay? X equals 2 is absolutely right, Hannah. This line is x equals 2, okay? So what I'm getting at here, anytime we're asking for the axis of symmetry, it's going to be x equals a number because that is how you draw, or that is the equation you get from a vertical line. Okay? Now, it is going to be the x value over here of our vertex. The axis of symmetry occurs at the vertex. It's a vertical line at the vertex. So it's going to be x equal whatever the x value is of our vertex, so this is going to be x equals h. I got a lot coming at you today. You've got to be locked in today. So here we go, example 1. Transformations of quadratic functions. Here we go, this is in vertex form. First of all, how do I know it's in vertex form? It's got all the components. It has a k value outside. It has an h value inside. It's got an a value, and we're squaring something in parentheses. Okay, first of all, what's the vertex here? It's going to be, Tristan? -3, 4. So, -3, I can erase this line now. -1, 2, 3, and I'm going up 4. 1, 2, 3, 4. There's my vertex. Okay, my axis of symmetry is going to be what? X equals -3, okay? I'm going to do this in a different color pen. My axis of symmetry is right here. This is going to go open up or open down. It's going to open down because it's -2. Okay, so what we're going to do now is we're going to make a table of values. I'm going to call that x and f of x. What x value should we plug in?
5.
Let's try negative 2. Again, picking negative 2 because it's right next to our axis of symmetry. So here we go. What's negative 2 plus 3? 1. What's 1 squared? 1. What's 1 times negative 2? Negative 2 plus 4 is 2. So our point, negative 2, 2 is on the graph. Negative 2, 2 is on the graph. And then I can mirror that. Have we done anything new here yet? No, nothing new. Nothing new. Let's plug in negative 1. So I'm going to plug in negative 1 here. What's negative 1 plus 3? 2. What's 2 squared? 4. 4 times negative 2. Negative 8 plus 4 is negative 4. So negative 1, negative 4 is on the graph. Negative 1, negative 4. And then I can mirror that. And there's my parabola. Nothing new there. Okay, next part says, can we rewrite this function in a different form? Here's what I mean by that. What does squared mean? Okay, squared means it's going to be a parabola, I agree. Outside of this, what we're doing right now, what is the idea of squared means in an Algebra 1 mind? Multiply by itself. So if I'm going to rewrite this, I can mathematically, it's legal to mathematically rewrite this to say negative 2 times x plus 3 times x plus 3, because it's squared, it's timesing by itself, plus 4. Okay, now here's what I'm going to do. I'm going to FOIL this guy. What's x times x? X squared. What's x plus 3? X times 3, excuse me. Plus 3x. What's 3 times x? 3x. What's 3 plus 3? 3 times 3, excuse me. 3 times 3? 9 plus 4. Can I combine like terms here? I can. I'm going to get negative 2 times x squared plus 6x plus 9 plus 4. Now here's the question. Do I add 4 first, or do I need to multiply by negative 2? Have to multiply by negative 2. So here we go. I'm going to distribute my negative 2 throughout there, and I'm going to get negative 2x squared minus 12x minus 18, and then I have this plus 4. What's negative 18 plus 4? Negative 14. What I've done there is I've shown you how you get a quadratic from vertex form to get it into what we now call standard form. Okay? This is a quadratic in standard form. So leading into this next box. Standard form looks like this. You're going to have to kind of write small. And actually I'm going to write towards the top here. ax squared plus bx plus c. I'm going to say a comma b comma c equal numbers. Okay, a, b, and c just represent numbers or coefficients. Okay.
The very first vertex form, like in that box, it's supposed to be squared.
Did I not square it up here at the very, very top?
Should it be?
It should. Did I? No. Make that note, guys. I forgot to square it. It should be squared up there. Thank you for pointing that out. Okay. Now, from this in standard form, we're going to have to graph it from being in standard form. Now, we have some things that we can find, axis of symmetry, vertex, y-intercept. We're going to start with the y-intercept. If it's in standard form, the y-intercept where the graph crosses the y-axis is always our c value, the number at the very, very end. Okay? Our axis of symmetry, remember, axis of symmetry is x equals something. Okay, and it's this. Opposite of b divided by 2a. Now, what do I mean by b and a? Well, that's over here. This is our a value. The a value is the number in front of our x squared. The b value is the number in front of, x. Our c value is the number that's at the very, very end. So if we take the opposite of our b value, divide it by 2 times our a value, that will get us our axis of symmetry. Okay? Now, our vertex, I know my vertex is going to be a point, isn't it? And I know the x-coordinate of my vertex is going to be my axis of symmetry because I know the vertex lies on the axis of symmetry. So this is going to be negative b over 2a. It's going to look kind of ugly to start, but then once we start rolling, I think it'll come full circle. Now, I'm going to write this down, and I'm going to talk about it here in a minute. I'm going to say f of negative b over 2a. Guys, what does f of 2 mean? I just made that up. What's f of 2 mean? That means I'm going to take 2 and plug it in for x. Well, from negative b over 2a, I'm going to get some number. And then from there, I'm going to take that number and plug it into my function to get my y. Okay? Here we go. We're going to do this in an example, and we're going to refer back to this box here. First thing that we should do is find my axis of symmetry. Well, that means I need to do x equals opposite of b over 2a. Now, what's my b value here? Shelby, what's my b value? 2. Great. What's my a value?
X squared.
It's the number in front of x squared, which is 1 here. So I'm going to write this out. A equals 1, our b value equals 2, and our c value equals 1. You don't have to do that every time, but it's good to do it the first time. Okay, so what's the opposite of my b value? That'd be negative 2, right? What's negative 2 divided by 2 times my a value, which is 1. So I'm going to get negative 2 over 2, which is negative 1. What does that mean? What did we just do there? That is my axis of symmetry. So x equals negative 1 is my axis of symmetry. I'm going to draw that. Now, guys, I know the axis of symmetry lies on that line. Would you guys agree with me? So what I'm going to do is I'm going to plug into my function this value, negative 1. So I'm going to evaluate the function at negative 1, and that's what this idea is. Hey, right now, the number that we got for this was negative 1. So what I need to do is find f of negative 1. That's all this means. So here in this problem, my axis of symmetry was negative 1. So that's the x-coordinate of my vertex. Now I'm going to plug that into my function. So here we go. I'm going to do f of negative 1 equals, write it all out, negative 1 plus, or squared, plus 2 times negative 1 plus 1. What's negative 1 squared? That's 1, right? Plus, what's 2 times negative 1? Negative 2 plus 1. What's this going to give me? What, Kim? That's going to give me 0. So f of -1 equals 0. What does that mean? Liam?
The point is right on the x-axis.
Okay, that means my point, -1, 0, is on the x-axis. So here we go, -1, 0. That point is my vertex. That point is my vertex. Okay, how many points do we need to graph?
5.
We need 5. The good news is if it's in standard form, what does our C value tell us? That's our y-intercept. I know the graph's going to cross the x-axis at 1. What can I do at that point?
Mirror it.
Mirror it, can't I, Tyler? Yeah. We can mirror the thing. How many points do I have? Gosh darn it, I better get a 5th, shouldn't I? What point do you think we should plug in? Can I plug in -2? No, there's already a point there. Can I plug in -1? No, we already did that. Can I plug in 0? No, there's already a point there. -3 or 1? Which one would you guys rather do? I'd much rather do 1, right? So here we go. And you don't necessarily need to do this. What's 1 squared? 1. What's 2 times 1?
2.
Plus 1. What's 1 plus 2 plus 1? 4. So that means the point 1, 4 is on the graph. 1, 1, 2, 3, 4. Mirror. There we go. Whew. Gosh, that was fun. We just graphed a quadratic in standard form. I'm gonna retrace our steps. What did we do? First, we found the axis of symmetry, opposite of b over 2a. We got -1. I drew my dotted line there for my axis of symmetry. I then knew that my vertex lied on my axis of symmetry, so I plugged in my axis of symmetry. And I got 0. So -1, 0 was my vertex. I plotted that point. I then knew that my C value was my axis of symmetry. I plotted that point right here, and I mirrored it. And then I plugged in a new point. I didn't even write it in my chart. We plugged in 1, and we got 4. Holy smokes, that's a lot, isn't it? I've got good news. I'm not going to do all the notes. Okay? I've just made that decision. We're not going to do all the notes today. I have to go a little bit further, and then I'll give you work time. Is that fair?
Yep.
Okay? Okay? Do this one on your own. Go. Okay, I saw a lot of good things out there as I was going around. Got a lot of good questions, a lot of just small errors. Let's talk this through. First thing we need to do. AOS, axis of symmetry, which is x equals opposite of b over 2a. Opposite of b is going to be +4 over 2 times 1/2. What's 2 times 1/2? 1. So what's 4 divided by 1? 4. So x equals 4 is my axis of symmetry. I'm going to draw that in.
I recommend
Now what do I need to do? The next thing I need to do is to find my vertex. I know my vertex is going to be along my axis of symmetry, so I'm going to plug in 4 into my function. So f of 4, I'm going to write this out, equals 1/2 4 squared minus 4 times 4 minus 2. Okay? I do exponents first. What's 4 squared? 16. Half of 16 is 8. Minus 4 times 4 is 16, so minus 16 minus 2. What does that give me? I should get negative 10. So f of 4 is negative 10. That means my vertex is at the point 4, negative 10. This is huge. Order of operations, we have to square first, then multiply. Now, from here, I know my y-intercept is a very, very easy step. Naya, what's my y-intercept here? What'd you say? Negative 2. Graph's going to cross my y-axis at negative 2. I can then mirror it. This is 4 units from my axis of symmetry, so this has to be 4 units from my axis of symmetry. We need one other point. What should I plug in? Negative 1 way over here?
3.
You certainly could plug in negative 1. I don't think that's our best option because, yeah, we're getting further away. I think somewhere in here, but, personally, I like 1. Up until this point, it's been staying really, really close to there, to our axis of symmetry, but 1's an easy number, isn't it?
Yeah.
Again, you could have done negative 1. I heard 3 being said. You could have done 3. I'm going to plug in 1 because I think I can do maybe that in my head. Okay, now if I plug in 1 here, what's 1 squared?
1.
1. What's half times 1?
0.5.
It's 0.5, right? So this is going to be 0.5. Minus, what's 4 times 1?
4.
Minus 4, and then minus 2. So what's 0.5 minus 4 minus 2? Negative 5.5. So at 1, negative 5.5. 1, negative 1, 2, 3, 4, 5.5. Mirror it. Questions, comments, concerns? Guys, we're going to do one more thing. I'm going to talk about maximums and minimums. It's very similar to what we've already done. Okay? Now, a maximum and a maximum is the highest point on the graph. A minimum is the lowest point on the graph. Okay? So if I'm going to have a maximum, does the graph need to open up or open down?
Up.
Let's try it out. If it opens up, don't draw this. If it opens up, are these arrows ever going to stop?
No.
They're going to keep going forever and ever and ever. So do I have a highest?
Yep.
No.
Because it's going to keep going. But I have a lowest point right here. So if we're going to have a maximum, the graph has to open down. Okay, so our A value has to be negative if we're going to have a maximum. This is the point that we're talking about. What's the highest point on the graph? If we're going to have a lowest point on the graph, it's going to be our A value has to be positive. Now, this point here that I locate as the maximum, and the point here that I located at the minimum, where is that point? Rachel, nice and loud. Is that the vertex? It is the vertex. Okay? Don't we already know how to find the vertex? Yes, we do. So to find the maximum and minimum of something that's in standard form, well, regardless, the maximum or minimum is the y value or y coordinate of the vertex. Okay? Here we go. Here we go. There's my function. 4x squared plus 16x minus 3. First of all, is that going to have a maximum or a minimum? It opens up, which means we have to have a minimum value. I'm going to circle that. Now, to find the minimum, we're going to find the y value of the vertex. So what we need to do first is x equals opposite of b over 2a. Opposite of my b value is negative 16. My divided by 2 times my a value, which is 4. So this is going to be negative 16 over 8, which is negative 2. So that tells me my axis of symmetry is at negative 2. I'm then going to plug negative 2 into the function. So I'm going to do f of negative 2. It's going to be 4 times negative 2 squared plus 16 times negative 2 minus 3. What's negative 2 squared? 4. What's 4 times 4?
16.
This is 16. What's 16 times negative 2? Negative 32 minus 3. So 16 minus 32 is negative 16. Negative 16 minus 3 is negative 19. So that means my vertex is at the point negative 2, negative 19. So my minimum is the y value, which is at negative 19. So let me just sketch a quick graph for you to understand. My axis of symmetry is at negative 2 right here. The graph is going to look like this. It's going to open up. And down here is at negative 19. Okay? So the domain, what is domain again? The x value. Great, Cole. I want to know, hey, what x values is the graph taking up? What x values is the graph taking up? Everything. I've got arrows here. I didn't draw this very nicely. But those are going to keep going. Those are going to keep going, meaning I can plug any value in for x. So the domain is infinity to infinity. So I'll say negative infinity to infinity. Or we could have just said all real numbers. Remember, this is interval notation. Our range is our y values. So where on the graph is our y values being used? Negative 19 is my lowest y value, isn't it?
Yeah.
What's my highest?
Infinity.
Infinity. So here we go. Negative 19. Now, can we go to negative 19?
Yes.
We did, so I need to have a bracket.
Why does it need to be a bracket?
Great question. And let me finish here. If it's a parenthesis, it means we're not including that number. I can never get to infinity. Okay? But I can get to 19. We're just saying, hey, 19 is in my list.
So it would just be one bracket, one parenthesis.
What's that?
It'd be one bracket, one parenthesis.
Yes. One bracket on the left, parenthesis on the right. Okay, here we go. Now, this idea of increasing or decreasing. If I were to look at this part of the graph, and I were to think about, am I increasing or decreasing here?
Increasing.
As I go from left to right, I'm going downhill, aren't I? So I would be decreasing. If this represented the money in my bank account, which sometimes it does, my money is decreasing. Okay, so where am I decreasing? Well, I'm decreasing to the left, in this case, to the left of the axis of symmetry. So I'm decreasing from, or excuse me, I'm decreasing from negative infinity to where?
Infinity.
To this line right here. What's that line?
That was
That was -2. Now here's the question. Am I decreasing at -2?
no.
At -2, I'm neither increasing nor decreasing. So I'm not decreasing at -2, so I'm going to have a parenthesis there. So that means I'm increasing on that part of the graph. So I'm increasing. What's my lowest x value where I'm increasing? That's -2. What's my highest x value that I'm increasing?
Infinity.
Infinity.